Thanks everyone for making it to the session today. My talk is titled Stop Building AI Like Traditional Software, and you'll kind of see why I'm getting to that point. Let's get started. Um, so today I'll be introducing something called continuous calibration, continuous development. And before I kind of introduce that concept, which I have picked up over the past few years of building AI products, I will also introduce you to why that mindset came around and why a lot of people think of building AI products as traditional software and then they forget the key differences that AI systems have. And I'll kind of build the story from there and also give you a lot of backing as to why we came up with this concept of continuous calibration, continuous development. A little bit about me. Thanks for the wonderful introduction, but a little more about my background is I was an AI researcher in my past life. I have about 35 plus research papers in top AI conferences. And my advisor was Alan Black. And if you come from the machine learning world, from the NLP world before LLMs happened, Alan Black was a popular professor. Anyway, I was also an early member at the Alexa research team at Amazon and also worked on search and recommendations at Amazon using graph neural networks. Over the past 2 years, I worked at AWS as a tech lead for an org that we call Gen AI Innovation Center, where we build AI solutions using our existing Bedrock, which is our AI offering. And just about 4 months ago, I left AWS and now I run an AI consulting firm. And the whole idea is to build AI solutions for companies and also do it with a very forward deployed mindset. Which means we enter your company, we start understanding your ecosystem and also build solutions for you. More about it you can find in my LinkedIn, but that's kind of my background. I have both of a research as well as an enterprise background. I will walk you through a bunch of lessons from 2023 to 2024 and then 2024 to later, and which will help build up why we came up with continuous calibration and continuous development, right? And remember, in 2023 to early 2025, I was part of AWS, and I was a tech lead at Gen AI Innovation Center. And these are all the lessons I learned from building about 30 plus use cases while at AWS. 2022 November was when ChatGPT came out. People were going gaga about it. A lot of consumer use cases came into picture. People were chatting with ChatGPT and it was seeming super fun. But then enterprises also started thinking, how can we use this for our own use cases? Having something like a ChatGPT is good, but then it doesn't really serve our data sets or our ecosystem. So what can we do about it? And that's when we saw a lot of common use cases. Two big use cases that we saw for enterprises were find anything fast, right? Which essentially companies had a lot of unstructured data sets and structured data as well. And they wanted a chat GPT over their ecosystem, right? And that's kind of the very common use case that we saw in 2023. The fancy term for it, you probably heard of it. It's called retrieval augmented generation, or RAG. Essentially means pull up information from our knowledge base, summarize it for us, and answer questions. And the second common use case that we saw was on turning messy data into insights, right? Companies have a lot of SQL databases, relational databases, and they wanted methods to extract data or to transform that data and build analytics. It was previously done through code, but now folks wanted things like text to SQL or text to code so that they could have a lesser bar for people who could actually talk with their data and not really have domain experts or data scientists work on this. So these were very common use cases that we saw in 2023. There are a bunch of public examples that I worked on. We worked with a ISV called Imply Data, where we built a chat with your data system on Druid SQL, which is their version of SQL. We also built a geoscience copilot for Halliburton and also built a loan officer assistant for another global bank. So these are the kind of use cases that we kept seeing. Now, remember that in 2023, there were no AI engineers or AI PMs or all of those AI roles that we talk about today, a lot of the people who started building, a lot of the teams that started building these solutions essentially came from two backgrounds, right? One of them was software. They were software engineers who understood, system architectures well. They knew how to build CI/CD pipelines. They understood how to design APIs, scaling, DevOps, and all of the software practices, right? And then there was folks like me who came from the machine learning or data science background. And what we knew was, how do you play around with your data? Do you know if your data is ready? What kind of evaluation metrics should you be building? How do you build up observability? How do you do feature engineering and things like that, right? And both of these backgrounds our team also consisted of folks in these backgrounds, and we came together to actually build generative AI solutions. And we figured out that the extra thing that you need to be learning was to understand prompt engineering, because that was a new field that both ML and software folks hadn't really played around with a lot. And then more around as RAG became more mature, there were vector DBs and stuff like that. This was pretty cool because we had both the software and machine learning background, and all we had to do was augment that with the latest generative AI principles, right? And then we did about 14 use cases that year from 2023 to 2024. And having come from both of these backgrounds, we learned two important lessons, right? And one of those lessons was, one is that users will interact in surprising ways that you cannot predict upfront, and that AI evaluations need deeper design, right? Remember that if you're a software engineer or even you've worked with machine learning, a lot of user behavior is very, on a high level, is kind of predictable, because you have your users, you probably have a UI which has clicks, buttons, options, forms, and things like that. And you have a backend connected to that, right? Which is probably connected to servers, databases, and stuff like that. Now, with AI systems, your interaction layer becomes a lot more ambiguous, in the sense that users are not dealing with menu buttons or clicks and things like that. They're dealing with natural language interaction. You can see the figure on the right, where you're probably having voice or chat or video and things like that, which makes things a lot more harder to predict and kind of design for, right? You're not designing for guaranteed behavior, you're designing for anticipated behavior. And that was a huge learning for us when we started building these systems, because you really need to spend the time to think about how users will interact with your system, what kind of sentences they might come with, and just the fact that each of us communicate very differently. So there has to be that understanding of how users would communicate with your product. And the second lesson we learned is that evaluations need deeper design. Again, remember, even what the AI model predicts is natural language, or it's probably voice and things like that. So you really need much smarter ways of evaluating if a use case was successful. You cannot rely on traditional software tests like unit tests or integration tests and things like that. Neither can you rely on very traditional machine learning metrics like precision, recall, and stuff like that, because those were designed with classification or regression in mind, right? Now you have both users interacting with your systems in very unpredictable ways, and the AI model is also generating responses that are much more free flow than before. So these were two important lessons that we learned, right? One example is when I said we were building for a global bank, we were building a loan officer assistant. Turns out that the underwriters who were using this assistant started asking questions that we did not anticipate, right? For instance, they said, what exceptions did regulators flag for large loans in this section? And we just had a RAG system that was built on top of policies, and we did not have a historical view of the data. And they were also trying to cross-check precedent style cases like lawyers and things like that, right? And we figured out that there was data incompleteness in order to serve these features. And even as just a ChatGPT user, you will kind of see that maybe from 2023 to now, the kind of questions or the kind of queries that you ask ChatGPT or Claude or Gemini or whatever this is has evolved significantly, right? The patterns of interaction have evolved, and we need to, as builders, account for that evolution. So in 2024, we thought, okay, that makes sense. Those are some important lessons. And we said, from now on, we will be building solutions with quicker iterations so that we understand user behavior as quickly as possible, and we can evolve our system to do that. And we'll also think of much smarter evaluation metrics because older metrics no longer work, right? These were like two mindset shifts we had, which is, run small measurable iterations in order to gather user behavior quickly. Don't wait for your final product to be out there. Build smaller iterations so that you know how users are interacting with your system. And the other thing was, again, define a very clear success metric, whether that is user feedback, task completion, and along the way, check for intermediate signals as well, right? If you're building a text to SQL system, you could have a check in between to just make sure that the syntax of the SQL makes sense. You could also, if you have tool calling agents and things like that, you could have intermediate check, make sure that the right tool was called. Than looking at the entire, final response of whether it was successful or not, try to have intermediate metrics as well. If you're building a RAG pipeline, can you think about how good the retrieval was and stuff like that? So think of ways to evaluate your pipeline, break it down instead of looking at the final action, right? And then, test all of these components separately and stuff. And we also figured that since these metrics had to be so open-ended as compared to traditional machine learning metrics or software metrics, we also started building LLM judges or AI judges that could replace human judgment and could scale human judgment, right? And if I had to summarize this in a single statement, it would just be that the biggest mindset shift for us was that think of your AI system as an intern. It will not be perfect on day one. Regardless of how much groundwork you do to build this system, you will see that users will always come up with behavior patterns that you never expected. So it won't be perfect on day one, but think of ways to build iterations and to also collect feedback so that you can iterate quickly and get to a point where it starts performing well, right? And even as we build these solutions for customers, in early stages, when it went to production, we would always iterate weekly. We would look at the data weekly. We would try to improve our systems weekly. And as we started reaching a point of convergence where we knew a lot of the user patterns, that's when we extended that iteration to, maybe monthly or bi-monthly cycles so that, the product was stable enough, right? So that was one huge mindset shift that we made. We were in the middle of 2024, and we have picked up these two new, concepts, which was AI evaluations and also shorter iterations, and we were doing pretty well. And that's when the whole world started talking about this new concept, right, which is AI agents. From 2023 to 2024, a lot of the enterprises, their mindset around AI was very chat system-like, or RAG and things like that. But then not even late 2020, maybe early 2024, people started thinking a lot more about not just chat systems, but also agents that could perform tasks end to end. Now, there's a lot of debate on what agents mean, but at the high level, it just refers to systems that can perform tasks end to end and basically complete workflows, right? And then we saw that the kind of use cases that we started getting from enterprises looked a lot more different in 2024, right? Instead of them coming up with things like, can you build an internal search system for us? Can you build an insights can you build a text to code kind of system? All of their requests were more of, can you automate entire back office kind of workflows for us? Because now you have agents, you have the mindset of agents that could call other tools, that could have memory and things like that, right? And some of the common use cases that we saw back in late 2024 to 2025 was things like customer support automation, or for the global bank that we worked on, they wanted a more mature use case where we were also doing loan underwriting assistant. Instead of just answering questions, it could also help you do the underwriting and could kind of fill in some parts so that underwriters could spend much less time on doing those laborious things, right? So we were like, cool, I mean, we've already done this. There's not a huge difference. It's pretty much the same pipeline, just that the scope of work increases. So we're like, okay, we're the best team that exists. All of you will get agents. And enterprises were kind of super enthusiastic about the concept. And we're like, we've got this, right? But then and remember, I also went through these extra things that we'd picked up in that 1 year. We were all from a machine learning or software background, and we'd picked up all of these things about evaluations, about iterations, prompt engineering, vector DBs. And we were like, okay, we're experts at this, right? And then we built a customer support agent for a company. Unfortunately, I won't be able to divulge the name, but we built it for a retail company. And the idea was to classify tickets to the right department and to also retrieve resolution documents or standard operating procedures or SOPs and provide an answer and follow up on user questions. Typically what your customer support agent would do, but then automating that entire workflow, right? And we kept those two principles that we kept in mind, like were, build iterations, deploy early and gather user data, and also have good evals so that you know where your system is going wrong. So we were like, okay, this is pretty good, and we put it into production. And then boom, we deployed it to a very small cohort, of course, not to everybody, all the customers that these folks had. But the AI agent was shut down in 5 hours, and we had to spend a lot of time doing damage control, right? We had the dream team. We'd built a wonderful solution, but why did it fail? There were 3 reasons. One was we had limited initial data on how users interacted, what kind of questions that they would ask the system. But this was expected, right? We kind of knew that it is impossible to get all that data up front. And we had in our mind that we're going to build iterations. But then another thing that happened is the error started rippling because of a wrong routing. It would pick up the wrong SOP, and then agent would spiral into nonsense. And users were frustrated, right? Remember that when you're building your iterations, you want to build them in a way such that you don't frustrate your users. We didn't think of that. We thought, okay, we're going to do error analysis. We have evals in place, and we're going to build a better version each time. But what happens during that time when your agent is not up to the mark yet? You cannot really put it in front of customers. And that's kind of the issue that we saw, which is users were getting super frustrated, and they were demanding that real human agents come in. And these human agents who were there faced a lot of backlash from angry customers because there were no humans in the loop, right? And that's why it had to shut down. And that's kind of where I come to this point of the blind spots we actually ended up missing, right? From 2024 or 2023 to 2025, the huge mindset shift that people had, or something that we didn't really take into account, was that use cases were moving from augmentation to automation, which means there were much higher stakes. Just having the right set of evals or building the right iterations were not enough. And full automation could quickly break user trust, right? As soon as you put these AI systems in front of customers, you want to make sure that they have a seamless experience as before. And we did not think about that. And that's where we came up with this concept of agency control trade-off, which means that every time you give your AI agent more agency or like more autonomy to do something, to take decisions, you as a human or you as the developer are losing control, right? And you want to make sure that when you're losing that control, your AI agent has built that trust, has built enough trust to do it, right? And we also learned that domain experts remain super critical until the intern or the AI agent matures, and decisions must be handed off to real people if things go wrong, right? So on paper, agentic AI use cases could be built in a similar way as RAG or as other chat kind of systems. But then remember that people are not super frustrated when they ask ChatGPT for a question and it comes up with the wrong answer, because they're like, maybe it doesn't know about something, right? I'll ask it in a different way. But if you go to a customer support system and you ask a question, you're trying to get a resolution, and the support bot starts saying, some nonsense, you get a lot more frustrated because we expect that support systems work a certain way. We are not ready to, take any, mishaps the same way we would do with ChatGPT, because that's just a chat system. With a support system, you actually want, you're working towards an outcome. You want a resolution as quickly as possible. And that's also the mindset shift that we kind of missed. And that's where we came up with 2 new learnings from 2025. A lot of this builds on top of what we learned in 2024, but essentially AI systems are non-deterministic, and you're designing for likely behavior, not guaranteed behavior. And that's where, we had all of these things around quicker iterations, evals and stuff. The second thing that we learned was, as a builder, you need to plan for the agency control trade-off, right? Which is, if you let AI systems make decisions for you, then be sure they're well tested, and do not automate fully on day one. Try to make sure that there are humans in the loop. There are points where seamless switching can happen so that your user experience doesn't get affected. This is one of the biggest reason of coming up with the CCCD pipeline. And that's where we put together this framework, which is called continuous calibration and continuous development. development. And I built this framework from the learnings that we had both from consulting as well as working for AWS. And we use a lot of this when we build for customers as well. The idea is pretty simple. It's to come out of your mindset of a CI/CD kind of an approach, but think of an AI system as something that needs continuous calibration. And you're continuously sampling behavior in order to calibrate, right? And the iterations concept still remains the same, but we say that when you're building solutions, AI solutions, start building solutions that are very low agency first and give higher agency to your system over time, right? You kind of see this diagram where you say, as you go through it, increase the agency and lower the control. Don't give super high autonomy or agency to your system on day one, right? And it has two parts of the loop. One of it is continuous calibration, and the other is continuous development. And I'll just walk you through each of these. It's pretty simple at the face, but it starts to make a lot of sense when you start building AI systems, right? The continuous development side of the loop basically says start with a small, high control and low agency capability for your AI product, whatever that is, and plan to increase the agency over versions, right? And in order to understand what the capability should be, collect a reference data set that shows what good behavior could look like, and then set up the application. And you set it up with the simplest architecture that's needed to support the capability. And 3 is to design evals, right? Create custom evaluation metrics, which could help you track performance and accurately catch failure points. These 3 things are essentially what most people would do, which is the development process. The fun part happens after your deployment, right? Like once you've thought about the continuous development or the development part, you can go out there and deploy your product to a small user cohort. But what you do after that is a lot more important, which is the calibration, right? You think about how you could run your evals for a subset of the data, for a subset of the real user interaction, so that you can kind of walk backwards and understand what to improve. Then you analyze recurring failure modes and behavior patterns in those logs and make targeted changes that evolve into your next version, right? And kind of do this until you get to a point where a particular iteration completely functions well. And you're also scoping features in a way that you increase agency over time, right? If all of this feels a little theoretical, I can give you a few examples of what this could mean, right? Let's say you're trying to build a marketing assistant for, your enterprise. Your different iterations moving from, high control to higher agency would be your V1 could be something like just draft an email, ad or social copy from prompts, and then have a human review them and publish them, right? And your V2 could be to build a multi-step campaign and run them. Now you're giving your system a little more agency. And your V3 could be to launch, do A/B testing and auto-optimize campaigns across channels. So you can kind of see how you're slowly increasing the autonomy and all through the process having humans so that they could guide the process and also provide feedback. And if folks have used coding assistants like GitHub Copilot or even Cursor, Claude Code, and all of these. Claude Code and Codex are probably new, and they came up with a lot of loaded features. But if you've been in this space for a while, this is exactly how GitHub Copilot evolved, right? Maybe 2 years ago, you would see coding assistants just suggest inline completions and boilerplate snippets for you. And then slowly they started building up to generate larger blocks of codes for human review. And then now you can see coding assistants that can completely apply scope changes for you. They can submit pull requests. They can build autonomously, right? This is exactly the playbook that a lot of large companies or coding assistants used in order to build their products, right? So essentially, think of those versions that could help you slowly increase autonomy so that you're observing the patterns that exist. I have an example of a fully autonomous customer support and how you could build it. I will just go through a few slides since we're running out of time. This is a real example that we built. We have anonymized the customer that we built it for, but essentially we built 3 versions of the customer support agent. Remember, I said one of those times when we tried it, we had to shut it down in 5 hours. This was our second attempt to it, right? We first built just a routing assistant, which would route the ticket into the right department. And we would have logs of whether it was routed to the right department. Did a human actually change the department and things like that, right? That was very high control and low agency. And this gave us a lot of information about, is the agent able to understand where a particular query should be routed? And then we built a co-pilot, which would route and look up relevant standard operating procedures and past replies and draft a reply for a real human agent in order to answer the question, right? It would still have a human in the loop, but it would only make it easier for the human that's answering these questions. This was like medium control and medium agency. And then we graduated to the fully functioning resolution assistant, which would draft and auto-resolve common tickets using retrieve context, right? And all through this, we had a good set of evaluation metrics and also logs to understand what changes were happening. And we built into different parts of those CCCD loop in order to improve the system. I will show you a quick final product. So essentially, we ended up building a data flywheel where the V1 could basically determine if the system can classify and route tickets accurately. And what this helps you learn for the next iteration is how do users describe their problems, which departments are hard to distinguish, what metadata is actually useful. So it helps you do a lot of that context engineering into your system. And you feed that into your next loop, which is you build that out and then think about your next feature. You essentially have prompt clarity for routing decisions, you have clean routing data, and then you enter your co-pilot phase, right? Where you think about, can the system actually retrieve context and help, draft replies? And then you also log information about what human agents actually use or ignore, where retrieval fails, what gaps or inconsistencies are there in the standard operating procedures. And you can use that to then build into your third iteration, right? The third iteration is fully autonomous. And then you could still have learnings on where autonomy causes trust breakdowns, what tasks still require human escalation. Remember, although customer support seems like a very ripe use case for complete automation, there are still a lot of scenarios where you want to escalate to a human. So we also, bake that into our system and things like that. So essentially, once you build a system that gradually increases autonomy and log everything that happens, you're building a data flywheel for yourself so that your agent or the intern is slowly graduating and you're not losing the trust of your users. I will stop there, and these slides are there for your review. And we also have a post, a complete, a longer post on this on Lenny's newsletter that is also available for you to check out. So the takeaway here is let your AI system earn its agency through constant calibration, do not grant it prematurely, and build your iteration such that the user experience is not impacted while you improve your AI system.